Good morning, everyone. This is the first problem you have in that I do not speak Spanish. So hopefully you can understand my English with an Irish accent. My name is Tom Allen. I primarily, over the last 10 years, have been working mainly with IMO, probably more than 20 years. When Professor Arias asked me to speak, I have to admit he just wanted me to talk about passenger ships. But the more we spoke and the more we realized that there were going to be students in the room, I felt I should give you a slightly different story about passenger ships. I want to talk about IMO. You heard it mentioned this morning by both Professor Panadero and Mr. Rodriguez-Valero. It's a very important institution, and I think you need to understand within the maritime industry the importance that IMO has. So I'm going to talk about IMO, how it started, some of the passenger ships, and we will need to differentiate sometimes between passenger ships and cruise ships. But some of the passenger ships which caused big changes in the regulations, and some of the passenger ships which are now leading the regulations. And hopefully I'll finish where I hope IMO is heading in looking at new regulations. First thing you have to understand is IMO is part of the United Nations. There are many people who think it's just an organization set up by the shipping industry. It was set up by the United Nations. It's no different from any of the other organizations which the UN has set up over the years, but it deals only with shipping matters. It has the responsibility to develop all technical maritime safety, security, pollution, and these are all global standards. As a UN body then, it has the power to make international regulations which are usually adopted within the various member states. And it is the governments that have the duty to enforce those standards. And this is where Mr. Rodriguez-Valero, and I did understand some of the words that he mentioned, like IMO, ISM. This is their responsibility to make sure that those regulations are implemented on Spanish ships and on ships which are visiting Spanish ports. It's a large organization with 170 members. It has many non-governmental organizations which have a big influence on how IMO actually operates. The non-governmental organizations, while not as important in that they cannot vote on legislation, they can influence all the legislation that goes through IMO. As was mentioned, I used to chair the Maritime Safety Committee. If you haven't been across to IMO, I would strongly recommend that you do and spend a few days there with the Spanish delegation and just listen and understand how regulations are developed. Because in all of your futures, you will be involved somewhere on new regulations or the impact of those regulations which have come from IMO. Those are the main conventions: SOLAS, MARPOL, collision regulations, load line, and ISPS. I will not go into them in detail, but I only put these slides up to show you the variety of issues that are dealt with at IMO. It has a very much a United Nations structure. It has an assembly which elects a council. The assembly meet every 2 years. Spain is on the council, And the council members are elected by the Assembly, as I say, every 2 years, and they look after the general running of the organization. But all the work is done by the committees and the subcommittees that then come underneath them. And I will deal mainly with the Maritime Safety Committee because it's the one I know best. This is IMO meeting in plenary, and as I say, you can get up to 1,000 people in there. Trying to get agreement between about 120 to 150 countries with 1,000 people in the room is not easy. It can be very difficult. But if you look at SOLAS, you can see that just about everything you're studying is covered within the SOLAS Convention. If it's not within the SOLAS Convention, then it's covered in the MARPOL Convention. Now, those are the two main ones which will affect you, but all of this was developed, debated, discussed, and agreed within the IMO. So I can't stress any more importance on the work that they do carry out. I will explain to you in a minute how it started. But if you look at the Maritime Safety Committee, it now has 8 subcommittees. Up until last month, it had 9. But they're restructuring like everybody else. They're trying to save money, and they're cutting down on the meeting weeks. And they've merged various groupings now to form these new groups, which, as I say, still cover all of the issues that you will be dealing with in your college. Each of these will have representatives from the majority of countries around the world. And most of them will bring their own non-governmental organizations with them. These are just some of the ships that they deal with, so it's not just cruise ships or passenger ships or even ro-ro ferries. But they deal with all the types of ships. Anything that sails on the sea, it's dealt with at IMO. I have 2 facts which I always like to get out to students because I'm never sure that they understand it. 90% of world trade is carried by ships. Now, if you think about that, 90% of what's in this building probably arrived in Spain by ship. The reason I make that is it's extremely important. I'm not sure you remember in Iceland we had a volcano eruption which stopped all aviation in the northern part of Europe for about 8 days. Now, apart from some of the nice people who were stuck in the Bahamas and couldn't get home, nobody noticed the difference. If shipping stopped for those 7 or 8 days, then you have a different scenario. If you think 90% of the world trade, most of which is delivered when it is needed, then you will have queues at your petrol stations and your supermarkets. Shipping has a major impact on world trade, and you have to understand that foundation when you go forward. Passenger ships, they don't go back as far as people think they did. The first cruise was a transatlantic cruise in 1840, and it wasn't really until the 1920s that cruise ships really started in America. And they only started for a very simple reason. When you went to sea, you could have a drink of alcohol. Once you left the United States shores, you could drink. So a whole industry grew up out of prohibition. It's interesting to think. Whoops. Now for the ships that I think have had an impact on regulations and on shipping. The first one is the Titanic. When you look at that graph, you realize how small the Titanic is. This is a group of Royal Caribbean ships, and I have to thank them in case there's anybody here from Royal Caribbean for their slide. But the Titanic, in today's sizes, was a small passenger ship. In those days, it was the biggest one afloat. But when you look at the ships today, that was where it fits in the scale of things. If you look through the ages, the tonnage has almost doubled each time a new ship comes out, a new big ship comes out, where we finished up with Oasis of the Seas at 250,000 tons. I will speak about Oasis of the Seas later. But if we stick with Titanic, Titanic started the IMO. We didn't have international regulations before Titanic. The United Kingdom, which in those days was the biggest ship register in the world, set up what was called a bulkhead committee. You may recall that when the Titanic sank, there's too many buttons on this. The gash was about here, and the ship took a trim by the head, and the water went over the bulkheads into the forward compartments so that she went down vertically. There was not a bulkhead deck on the Titanic. So after the Titanic inquiry, the UK set up primarily a European, but it was an international group, to start looking at regulations. Because of the First and Second World War, most of this was delayed until the 1940s. And then a large group got together and they formed the IMO Convention. But it all came out of the committee that was set up to look into avoiding a similar disaster to that on the Titanic. So if she has any fame, that's the fame that it should be given, rather than some of the other fame that it is given. The QE2 and the Canberra, I mention those because those ships were built in the 1960s, before most of you were born. But in the early 1980s, we had to look at our passenger ships because they were needed for a different service. And when we pulled the files, we realized that not only were they built bit by bit in the shipyards in the 1960s, but every calculation was done by hand. There was no computers. So when I looked at the stability file and the damage stability file for both the QE2 and the Canberra, we had one calculation. The naval architect and the surveyor identified what they thought would be the worst damage, and they did the calculation based on that one damage. The file is that thick with calculations. So we had to put that on the computer, and we ran, I think, 12 damage cases. Of the 12 damage cases, the one worst damage was the one that they'd picked. But what it did was we started then to use the computer more to identify what we should be doing in looking at damage stability. So while those two ships didn't do anything really significant, they did force the United Kingdom and others to start looking at damage stability in a more proactive way. The Herald of Free Enterprise and Estonia, they're both there for a very obvious reason. They were both ro-ro ferries, and they both capsized. Now, out of those two casualties, we have a new raft of regulations which now impact on ro-ro ferries. One of them has already been mentioned this morning by Mr. Rodriguez Valero, and that's the International Maritime Safety Code. That came out of the Herald of Free Enterprise because we couldn't identify the person ashore with technical responsibilities for the ship. So the ISM code identified a designated person ashore. We didn't get much structure on that until the Estonia accident happened, and then we developed properly the ISM code. Many more regulations came out because for the naval architects here, we looked at water on deck, and I'm sure Professor Fasalis will explain more about that, but we started looking at model testing. And it's only really, I believe, since Estonia, when we started looking at model testing, and with the better capacity of computers, that we have really started to get a better understanding on the damage stability of ships. These ships brought in many more regulations, but those were the main ones, the big ones that we implemented. Sorry, a third one was that we also used the example of those two ships to stop building one compartment ships. Because in those days, we were still building ships that could only comply with damage stability with one compartment damaged. So at least we also introduced that with those ships. The QM2, I only put that up because she's a nice ship, and she's the only liner that we have in the world at the moment. But she's built for a different reason. She's built purely for speed. I put it up because of that slide, which gives probably a better understanding of the size of the Titanic against the profile of the Queen Mary II. She is, by any standards, a small ship at the moment. But if we now look at where we are at the moment, you can see the progress in the sizes of ships. This is only the Royal Caribbean fleet. The Carnival fleet will show the same trend. The Norwegian Cruise Lines fleet will show the same trend. And that is what has been happening over the last 20 to 30 years. Even today, the biggest number of cruise ships still sail out of Florida, where they all started. They still sail out of the States, but it is growing elsewhere. But the trends today are for more innovative and complex ships. And that's really where our problem is at the moment. They are getting so complex, they are going ahead of the regulations that were developed for these older ships. And that's a problem that we need to address, and I will come back to. There is a high demand on knowledge, information, and technical management. And this is where you come in as the future naval architects. But your biggest problem will not be the new ships that you'll be involved in designing. It'll be bringing the old ships up to the standard that they probably need to be at the moment. If we look at the Oasis of the Seas, this was probably the first ship that really pushed the limits on IMO's regulations. She's a big ship, almost 250,000 tons. She has a split superstructure. She has an atrium below and an open deck above, with cabins looking in on each side. We now have a garden in the middle of the ships. We almost have a forest in the middle of the ships. At the aft end of this ship, we have a boardwalk. It has a full-size carousel. It has ice cream parlors. It has a London bus up there somewhere. It has an auditorium at the aft end. This is not covered in SOLAS. At the aft end, we now have a 1,000-seater auditorium. They do diving displays. She is a big ship. How can she comply with the restrictions and the regulations? So, and I defer to Professor Fasalis because he did a lot of work on this ship. But they had to look at the open spaces that I showed you, the garden and the forest. And they had to make sure, even though it was open, you could have a fire. So we have longitudinal fire boundaries. We have transverse fire boundaries. You have furniture put in such a place so that if a fire doesn't start, it doesn't spread. There's a lot of risk analysis has gone into that arrangement. Probably more work's gone into that than on an existing ship complying with the regulations. Because it complies with the regulations, it gets a tick in the box. But you have to now start doing a risk analysis. And because the fire zones are probably twice the size allowed for in SOLAS, we have to do more risk analysis, and we have to address the fire zone boundaries in a slightly different way. In the atrium, we have fire bulkheads coming in from the sides, but when you have an atrium this size, you do need to close it up. So within 20 seconds, they can close those main shutters. It means you have to make sure that the whole space is clear and ready for it. But a lot of risk analysis has gone into this because the regulations didn't really cover this size of ship and what it was doing. On damage stability, you will recall that I said 2 ships, which only disappeared about 10 years ago, had 1 damage case. This ship had 740 watertight compartments. They carried out 10,000 damage cases. I doubt if there's anything on the inside of that ship that they do not know about. If you look at the curve which the Oasis had to comply with, it exceeded the curve for damage stability. But because of the knowledge that they have, and with slight alterations of the inside structure, they could achieve something like 0.98, 0.99 in the index for damage stability. Now that really is a step change for the industry. On the construction, they fitted double hulls in way of the machinery. This is now a recommendation from the Costa Concordia. One of the few recommendations that have come out is that we have a double hull in way of the main machinery spaces. They were doing this. This ship was designed in 2008, 2009, came out in 2010. They were already doing that because they identified ahead of time what would be needed in the future. We also did damage tests. Now, this isn't just this normal simple damage test that we've been doing on ro-ro ferries. The inside structure of the ship is also modeled so that they know every little compartment inside the ship, it is also modeled. When we did this in the tank at a 4-meter significant wave height, you could see the movement of water around the ship. This allows the naval architect to look again at his interior so that he can be aware of water, where the water can go, and put a mitigating feature in its place to stop it happening. On life-saving appliances, again, we couldn't fit 150-person lifeboats, which is required in SOLAS. If you're going to put on 150-person lifeboats, they would have extended past the length of the ship. So we built lifeboats with 370 persons. The gentleman in front of it was the master of the ship, and he's 2 meters in height. These are not small boats. They have 4 openings to load the passengers, and they load directly from the deck into the lifeboats and then are lowered down to the water. They are not on a davit. They are suspended underneath the superstructure on a much simpler system of lowering in. This again had to be risk assessed, analyzed, and tested to make sure that at least it complied with the equivalent regulations at IMO. the dedicated safety center within the bridge. We now have a safety center at the aft end of the bridge, which they built before the regulations came into force. They recognized that in an emergency, you need a space on the bridge where they can control the emergency, whether it be a fire or flooding or anything else, and that will then not affect the navigation of the ship. The captain or his team on the bridge can still look after the navigation of the ship while others look after the emergency that is happening. Now for the future trends. Ship design will most likely continue at an accelerated pace, and this is primarily because of technology. As naval architects, you probably don't realize it because you're coming in at this end. But if you speak to some of us older ones, when we were doing hand calculations, the progress in the last 10 to 15 years is amazing. You have so much power at your fingertips with technology, so much new technology coming out. It will eventually change how you look at passenger ship design, and this is for cruise ships and ro-ro ferries. The average size will get bigger. I'm not saying that the ships will get bigger than Oasis of the Seas. I think the Oasis of the Seas is probably as big as it will be for the future, immediate future. But as the older ships phase out, they are the smaller ships. And no one's building the smaller ships anymore, so they're being replaced by largers. So the average size of the fleet, the average size of ships in the fleet, is going to get bigger. But the novelty and the design solutions, which probably will be a problem for the naval architect, because the operator of the ship is going to go to an outside designer and he's going to look for a new novelty to go onto his ship. You're the ones who are going to have to make sure that your design can cope with this new novelty. And there are many out there. And you need to be careful how they fit into the ship. As I said, the amenities will enhance the guest experience. The safety design will benefit from new technology, and there will be a continued search for improvements in efficiencies. Efficiencies, energy efficiencies in particular, are very important to the operators. I know for one cruise line who last built a ship 4 years ago are looking for a 20 to 25% saving in energy usage in their new ship, and that's only in 4 years. Technology is going that quickly, you can achieve those aims. Now, post-Concordia, I couldn't leave it without putting in a slide, and I only put this slide in probably early this morning, because I thought you should at least see what is happening. They're starting to look now, because of Concordia, at the operational aspects of the ship. These are just some of the issues they're addressing. Musters was an easy one. Up to 2 years ago, you could muster your passengers up to 24 hours after the ship sailed. This is what happened with Costa Concordia. They waited 24 hours. The accident happened within 78 hours of sailing. Now you must muster before the ship sails. It's an easy fix. Passage planning, bridge access. Passage planning, they're now developing teams on the bridge so that when the passage plan is changed, it is questioned, and they make it agreed decision that this is the right change. You cannot change passage planning now on your own. Bridge access during the important times for a ship, where people like myself used to like to get onto the bridge and see the ship going out, that now is a clear space. The bridge team must not be interrupted while they're going into and out of ports. the nationality of passengers doesn't really make any difference for search and rescue. What they realized was that embassies were getting in touch to know if any of their nationalities were involved. They didn't know. They didn't have a record of it. Now they're going to have to do that. And finally, the most obvious one of all, the securing of heavy objects. They now have to do an inventory of the ship and identify any objects which could move in the event of a collision or heavy seaway, and make sure that there are issues in place which can handle that. There's a whole string of operational issues which now need to be addressed. Professor Fasalis will actually look at most of that from a design point of view as well. I hope he will.
No, I will.
The other trends are emergency response. Now, this also came out of the Costa Concordia, but we're also trying to look now at life cycle risk management and trying to put into place a sustainable system. I took away a lot of slides because I know Professor Fasalos will actually deal with this, but it really was looking to process risk at the design stage, which flows through to the operation of the ship. We need to stop looking at the ship for design and then looking at it in operation and doing the amendments. You need to look at the ship in the whole, from the design stage, through construction, through to operation. This is a slide which comes from Professor Fasalis' paper, and it's looking at the critical scenarios, looking at the vulnerability, how to reduce it, looking at the mitigation that you can put in place, putting together the emergency scenarios, looking at the design options, and again you can look at these at the design stage, never mind in the operation. And then looking at the time to capsize or the time to abandon ship. And if all of this is in place, then you have the risk controlled. And this is a methodology being developed, as I say, by Professor Fasalis, and he will talk about that. But one of the things that came out of that, and one or two of the cruise companies that I'm dealing with, you all know when you go on board a ship, the crew do two drills. They do a muster drill, and they do a fire drill. The one drill that they didn't do was an emergency response drill. They could look after fires and they could look after the musters, but in the event of a collision, what you have now is emergency response teams, specialist teams put together in the event of a collision, and sometimes you don't know where all of the damage is. Like the Titanic, it was all below water. In the Costa Concordia, it was down at the side. They didn't know what all the damage was. Now you have teams that are set up which can immediately go to all parts of the ship, identify where the damage is, contain the damage as best they can as a first stop, report back to their control and to the bridge, and then make decisions whether they can, if it's a small repair, they can handle it, or if they need to do something else to contain the damage. This is a process now which is on board a lot of the ships. It's a culture issue. You need to get this culture developed into the crew whereby safety is your main priority, and you have to have all of this in place when the ship is designed and going into operation. About 2 months ago, the Secretary General of IMO called a conference to look at ship safety in the future. And he called the top people in industry to come and explain what they thought of the regulations, what they felt should be done. Because he was getting concerned, as I was, that ships were now being built beyond the regulations. So they came up with 3 proposals to consider how to better integrate risk-based methodologies into the safety framework, ways of encouraging a safety culture beyond mere compliance. And for a lot of ship owners, their argument is, I comply with the regulations. That should not be a defense. Safety goes beyond merely complying with the regulations. And the third one, consider taking a review of the existing regulatory framework to meet the future challenges and, as importantly, the technologies which regulation can't keep up with. These are just some of the statements made by the people who were speaking. New regulations should not be a barrier to innovation. It should enable innovation, which means you have to get away from prescriptive regulations. Prescriptive regulation tells you exactly what to do, and if you just do exactly as you're told, then you're fine. Things have moved on. That does not work anymore. The regulation must be fit for purpose. You now have regulations within SOLAS that are not fit for purpose. They were probably developed for the 1948 convention, amended for the 1960 convention, slightly amended for the 1974 convention, and we haven't had a proper amendment since 1974. So we need a rewrite. I believe we need a rewrite of SOLAS. We need to look at an alternative approach and equivalence, alternative designs and risk-based approval, and we need to be proactive. This is one that came from the speech of Professor Fasalis and he has a concern over the grandfather clause. The grandfather clause means that if a ship was built to one set of regulations, even though new regulations come in during its life, it only has to comply with the first set of regulations. That means that in a 30-year life of a passenger ship, the regulations could have changed 9 or 10 times. But that ship only needs to comply with the first set of regulations that it was built to. That needs to be looked at. That needs to be changed. That at least needs to be discussed on how we take that forward. We need to put as much effort into channeling new knowledge and experience to improve the existing fleet. The same principle, we need to start to look at the ships that we have. The ships are operating at the moment make up 100% of the fleet. You can look at new designs for new ships on the drawing boards. Your problem is the ships that you have at the moment. They need to be looked at as well. And the other pressure to change regulations is that they're no longer compatible with current technology. Now, I've covered that 2 or 3 times. They just don't address new technology. And we need to take that on board. So in conclusion, many operators are now building beyond compliance. They're building beyond the regulations because they can't build the ship that they want to the new regulations. There are many equivalence and risk analysis now to give them more evidence and confidence that what they are doing is correct. And as I said, SOLAS is now getting too old. I think at IMO I said it's showing signs of wrinkles, but it really does need to be looked at. Prescriptive regulations are not fit for purpose in today's world. And the big argument during that debate was that the devil was always in the detail. My argument is the devil is in developing a safety culture from the design of the ship right through to the end of its life when it goes to scrapping. That is the Oasis of the Seas on its first voyage, and thank you very much for listening.
Now better. One question was evident in the evacuation of the Concordia was the difficulties on sliding the boats on the ship sides in big heeling angles. Is there any change of rules thinking of that improvement?
No, one of the things that I'm going to be looking at because of another group that I am with. But if you look at all of the photographs of Costa Concordia, the vast majority of the ships got away. They actually stopped lowering some of the boats because the original boats were coming back and picking up the passengers. So a lot of them did get away. But there was a problem when you got to the high side because the ship, they were getting stuck. But they pushed them out and they did get away. The lifeboats are designed to go down through an angle of 20 degrees. And within the prescriptive regulations, that's what the design criteria is. When you're designing a lifeboat and the davits, you need to make sure at an angle of 20 degrees either way. On the low side, it doesn't matter because you go straight down. But on the high side, what they need to be careful of is, and I think this might have been a problem on Costa Concordia, but I don't know, was the boats were getting caught because of the hull was not clean. There was bits coming out from the side, and the lifeboat was sticking on these on the way down. And because of the angle, it made it more difficult. And some of them were very small. It was only about 25 millimeters, maybe 2-3 centimeters. And it was steel structures around the windows. And the gunwale of the lifeboat was catching on these, going down. Now that's something which they're going to have to start looking at to make sure that in way where the lifeboats are going down, you have a clean hull, or you do something with the lifeboat to go over those. But that appears to have been one of the problems. But the vast majority of the lifeboats did get away.
Yes, I have 2 questions or 2 comments. One of them is if you can explain to the forum what is the way to work in IMO, because will be very interesting for the students to know the procedures and to know I think the freedom that have the people working in IMO to put on the table all the questions, all the techniques and all the things that they have. No? And the second thing is that you mentioned in your talk that the regulation must be adapted to the new technologies. But I think that could be the inverse, no? The reverse, that is the regulation in many occasions produce.
Yeah, it's 2 questions. The first question, Professor Arias has asked me to explain how you handle input into IMO. I could probably spend an hour explaining to you the process. It can be a very long process. Initially, a member state, if Spain has an issue, say Spain did some research, which was done here in the university, and you came up with a proposal to amend an IMO regulation, then Spain as a member state can do that. They can put in a proposal to the Maritime Safety Committee. It has to comply with some criteria, but if you can prove the need for that regulation, that's usually the main criteria that it has to get over. Once you've proved there is a need to do this, because it will improve safety or prevent pollution or improve security, then the Maritime Safety Committee, they will approve it. They won't approve what you want, they will only approve the forwarding of your paper to one of the subcommittees. You may recall that I mentioned at the beginning the various subcommittees at IMO. They deal with particular subjects. Now, they've all changed their names. Sorry, I've got too many slides. But say it was to do with damage stability. They would have sent it to the Design and Equipment Subcommittee. They would then ask for papers to be sent in to discuss the proposal from Spain. Now, think about this. The first one is the first year you put in the paper. The second year, because they only meet once a year, the second year it goes to DE. DE then decide, yes, they will deal with it, and they will put it on their agenda in the third year. In the third year, they will ask for papers, and they will probably debate it during the third year and the fourth year. They will then make a decision in the fifth year. They then put a proposal back to the Maritime Safety Committee in the sixth year, and if they agree, it will get approved in the seventh year. So you've thought about something in the university, you've done the research with the Maritime Administration, you've probably spent 3 years in doing it. It can be as long as 10 years before it can be brought into place. It's a very difficult process.
And then it has a period of grace until it's...
No, that's in the 10 years. That's in the 10 years. So IMO can be very slow. Now for Estonia and for 9/11, and I didn't touch the security codes, but for Estonia, they thought it was such a big problem with ro-ro passenger ferries, they appointed a panel of experts. I had the honor of being on the panel of experts along with Professor Arias. And we traveled the world to meet and come up with conclusions inside 1 year. We then submitted our proposals, they were debated, they were accepted, and they came into force the next year. So when IMO wants to, it can work very quickly. After 9/11 in the United States, they came and they wanted a security code for shipping because they could see the dangers of ships coming into ports and being a major security threat. That again, we met additionally, and within 12 months we came up with a new part to a chapter in SOLAS. That had never been done before. And it came into force the following year. So with IMO, it really depends on the importance of the subject, how urgently it is needed, and then how it goes through the process. I am happy to go through the process at another time. If you invite me back, I'll take you through the whole process, but it is a very complicated process. And it's something that students should be aware of. As I said at the beginning, you need to know where your regulations come from and how they're developed so that you have a better understanding in how you need to apply them in the design of new ships. Sorry, Carlos, I can't remember the second question. Yeah, one of the problems is coming up with a regulation when you do not have the technology in place. Now, you may wonder, you can't do that. If you need technology before you make the proposal. We had a problem with water ballast. Water ballast was carrying organisms within the water ballast. Ships were dumping it in ports because it was only water ballast, it wasn't oil. But it had organisms which had a major impact on the environment that it was moving into. So the problem was there. The environmentalists wanted a regulation to stop this happening. But we did not have the technology to clean the water ballast and make sure it was clean before it could be disposed. So the Water Ballast Convention has been delayed twice, I think, in implementation because the technology wasn't there. So you can have both. You can have technology driving change, and you can have change driving technology. And those are both two good examples of what happens at IMO.
You said the major problem is you comply with regulations instead of advancing them. But the way I understand it, the biggest problem is that regulations don't let you advance. Like the classification societies, they hinder the change, right? So how can you change that?
Yes.
This was the point I was making. The regulations now, in my opinion, and I need to be careful because I work for some other bodies, this is my opinion, are not fit for purpose because of that reason. Sometimes, if we take the example of the lifeboats, when Royal Caribbean came up with this design, they realized that with the number of passengers that they were going to have on board, which was 6,500 passengers, there's 9,000 people on this ship. They couldn't do it with the regulations. The first comment from the administration is, you can't do anything. You have to fit 150-person lifeboats. So they went to another administration who said, well, what are you proposing? It's a different attitude. No, you can't do that, to let's discuss what you're proposing. And I think a lot of administrations, and I hope classification societies, because classification societies, and there's one here in the room, I need to be careful because I work for some of them as well. Their regulations are very detailed, and as I said, sometimes the devil is in the detail. Sometimes you need to say, well, this is what we want to achieve. How best can we achieve that in the safest, and I'll quote Professor Fasals again, most cost-effective manner. Now, if you start from that, then you can start putting all the brains together to come up with another solution. When we presented this to IMO 5 years ago, the first question was, you can't load that boat in the same time as it takes to load a 150-person boat. And I've forgotten what the time is. They were only interested in, did the boat comply with that one regulation? Actually, as it happens, you can load that boat quicker than 150 because you've got 4 entrances and it's easy. You don't have people climbing over because they all go to their own little place. So we need to get past that, which is why I said we need to change the regulations. We need to change how people are applying the regulations. To be fair, DNV are here at the moment, and DNV were very much involved in this particular ship. So they were very much involved in doing the risk analysis with other teams and taking forward all of the changes that they could make for that ship because it does not comply with SOLAS.
It was GL with the lifeboats.
Oh, GL, it was GL with the lifeboats, but generally it was DNV. So we actually got 2 classification societies to go beyond the regulations. And if you can persuade them to do that, then you've made really the first step. But you have to prove that it's safe. And I think a lot of times you can prove that it's even safer than what's already in the regulations. I need a cup of coffee.
So, I just wanted to clarify something regarding the new regulations and interpretation of the classification societies, as I'm one of them. And one item is that we are involved in most cases on the behalf of flag administration. And the flag administration is the one who has to give their interpretation. By default, is the one written in SOLAS or any other convention. Apart from this, we make our own investigation and we deliver our own regulations regarding, for example, the alternative access, the alternative LSA, etc. And we give details about how to do it and a proposal to Ajax, or through Ajax to IMO, regarding their own implementation. So it's, I think, about the flexibility of the classification societies, I think we are quite flexible when we can do it. It's not always. We're involved in several life-saving appliances issues with the Spanish administration regarding some ships, and I think we all are involved in all these safety issues. It's not only that we are not flexible on that purpose. So I wanted to say that.
I wasn't trying to say that classification societies are not flexible. Their regulations aren't flexible. The classification societies are doing what IMO does. They're realizing that their own regulations are not keeping up with the new technologies. But a very important point, in that the equivalence and the alternative methods which you may wish to put on board a ship, while it's the classification society that will do most of the work, while it's the classification society or other bodies who will do most of the work, the main decision is made by the Maritime Administration. They are the only ones who can take the equivalence or the alternative arrangement to IMO. So you have to convince at all stages when you're coming up with anything which is outside the regulations, and that's a very important point. You have to make sure that the Maritime Administration for that ship is fully aware and agrees with what you're doing. Professor Vasalis is right, it doesn't have to be a classification society. The operator can go to other bodies, but you still need the approval
In fact,
of the member state.
There could be conflict of interest because we cannot do a design for alternative arrangements and approve it.
Well, that's the important point. That's why it has to be agreed by the member state. Excuse me, by the member state.
We go for lunch now.
Time for coffee. Time for coffee. Thank you very much.